Particles P and Q are attached to opposite end of a light inextensible string. P is at rest on a rough horizontal plane. String passes over a small smooth pulley which is fixed at the edge of the table. Q hangs vertically below the pulley. The force exerted on the string by the pulley has a magnitude of 4 under root 2. Okay, now what is this? The force exerted on the string by the pulley. It's some force exerted on the string. Here's the string on the pulley, and this force is exerted on the string by the pulley. So it should be somewhere in this direction. Let's say here's the contact between the pulley and the string, and here's going to be that force, 4 under root 2. Okay. The coefficient of friction between P and the table is 0.8. So that is mu. Show that the tension in the string is 4 Newton and state the mass of Q. Okay, so we have to find the tension and the mass. Okay, so tension, since this force is acting here, the other two forces would be here, tension, and the tension with respect to this point would be here because tension points away from the uh, point of observation. Okay. So now how do we find the value of T? Okay, so this force will also have an equal and opposite reaction in the opposite direction. That is because this string is not breaking away from, or this pulley is not breaking away in this direction. Even though there's a force applicable here, that means there's an equal and opposite force in the opposite direction that is balancing this out. So there's a 4 under root 2 here as well. Okay. So now look at this triangle. If I make a right angle over here, this is T, and this is also T, which I'm plotting over here. So this forms a right angle triangle. That means we can say that T square plus T square equals 4 under root 2. So 2T square equals 4 under root 2. So T square is equals to 2 under root 2. And then we square root this. Actually, I was supposed to square this. I did not use the Pythagoras theorem, right? So square this and then divide it by 2. So this becomes 2t square equals 16 times 2. The 2 and 2 gets cancelled. You take square root, we get 4 Newton. Okay. And state the mass of Q. So now tension is 4 newtons. So with respect to Q, this tension is going to point upwards and mass mg is going to point downwards. So T is equals to mg at Q. T equals mg. 4 equals 10 m. M equals 0.4 kgs. Given that P is on point of slipping, find its mass. Okay, now we need to find the mass of P. It's going to move. So we have tension in this direction. And since it's a rough table, this is going to be mu R. Okay. And then there's going to be weight, mg, or 10m. And there's going to be a normal contact force here. Okay. Okay, now to find the mass, we can do tension, which is the force towards the left, should be equals to mu R. So we already know the value of tension 4 is equals to, we know mu 0.8. So now we can find R. 4 upon 0.8, 5 newtons. Okay. So we have the mass of, we have the value of R. We still need M. R equals 10m by equating these two. So 5 equals 10m, so m equals 0.5 kgs. Part 2 is done. Part 3, a particle of mass 0.1 kg is now attached to Q. Okay, so now the mass of Q increases. There's another 0.1 kgs force. So now this mass is going to become, let's say this collective mass is 0.5 kgs. Find the tension in the string while the particles are in motion. Okay, and so now we're going to apply forward force minus backward force is equals to MA on both the particles. Forward force is mg, which is 0.5 into 10 mg, minus backward force is tension, is equals to mass, which is 0.5 times A. So 5 minus T is equals to 0.5 A. Now at B, forward force would be T minus mu R equals MA. T minus mu is 0.8. R is 10m. What was the mass for this? It was 0.5. So R is going to be 5. Oh, we already know that from here. Is equals to mass times A. Okay, now we solve these simultaneously and get the value of A and T. Noticed a mistake. This is supposed to be the mass of P, which had come out to be 0.5. So this is 0.5, not 0.8. Okay. So this is also 0.5 A. Okay, now we solve this and this simultaneously. And we get, solve it, you should get A equals 1 and T equals 4.5.